All right, hello. This is going to be a recorded talk of a talk that I previously gave at SRE NL, actually just yesterday, the 13th of November. And I figured I would record it because they weren't able to. And yeah, so you guys can enjoy it at home. We'll get into some, I guess, admin. Let's go here. This is on the internet already, so you should be able to see the slides. If not, this is kind of my pet peeve when I can't find the slides. I usually have a hard time reading the screen, so this is also kind of an accessibility thing where I always would want to look at the slides on my phone and kind of like take notes separately while I'm listening to the presentation. So this is available on my website, and I'm going to try to be better about this for any future talks that I give where you can find the slides and the notebook and a couple of other, footnotes, right? Anyways, now that that's out of the way, I can give a brief intro about myself. So I'm Thomas Mall, and I work at Booking.com as a senior site reliability engineer. And at Booking, I'm a team lead for the MySQL environment, specifically for the integration and testing environment. So we basically copy all production data. We do a couple of data pipelines, and we kind of give developers a production-like experience. But in this DQS or dev environment so that they can test their stuff ahead of time, and it's like a pre-prod integration environment. So we work on bare metal, we work on a private cloud, we work on AWS. So we're kind of building a lot of I work a lot with Python, we do a lot of Go, just kind of building out these distributed tools to make sure that these databases are able to be cloned in a reasonable amount of time, and that the availability is good and all that stuff. Previously, I worked at LinkedIn on the search team most recently, and then before that I was on the Hadoop or big data team, and I was building out GPU clusters to do LinkedIn's like first explorations into language models, which was pretty exciting. This was pre GPT and all that stuff. This is actually, we were training our own BERT model. Yeah, fun times. A lot of like installing NVIDIA drivers and making sure that performance was good, and integrating that into the Spark environment, and TensorFlow on Yarn and all that stuff. So yeah, this is actually a photo of me trying to summit Mount Shasta in California. It's a 14er, which means it's over 14,000 feet. And my friend Adam and I like hired a guide, and we went in late May when the weather should be perfect. But as you can see, we absolutely snowed on. There's still snow on the mountain, but we had to learn how to snow camp. So we had to like dig out our tents every morning, and then we didn't end up even summiting. It was too cold and too windy, and the wind up top where you have to be in a rope team was just completely infeasible to summit. So fun photo, want to go back. But yeah, this is my go-to kind of cool story photo. Now, the next part of this the joke landed, I hope, at S3 NL at the live presentation, but it's not going to be about generative AI, so sorry to bore anybody. This is not going to be the talk. This is instead going to be about something kind of simple, and we'll kind of work from a simple example, and we'll work our way up to kind of an interesting and kind of thought-provoking example here. And what I want to talk about are actually magic numbers first. So if you're a programmer, or you've looked at code in any capacity, you've probably seen these before. There are values that just kind of exist in code, and you think, well, maybe if we change that value one place, we should just use the same symbol, right, to represent this value, a variable name, right? But we really shouldn't. This is kind of a bad practice. This is the famous inverse square function from, I think it was Quake 3 Arena, and I think John Carmack was the one who wrote this, but don't quote me on that. And you can see here we have a couple of like magic numbers, these constants, like 1.5, which is 3/2, a number. We have 3/2 to float, and we have 0.5. We have this particularly crazy hexadecimal like floating bit hack thing, which is this code is famous for. So these are kind of what I'm referring to here are constants that probably should be stored somewhere else. They should probably have some organization and some structure to them so that we can better program on them. And we don't just want to have a name. A name is a nice abstraction, but we also want some more ergonomic abstractions, like a collection of magic numbers or magic strings. And then how can we actually build a hierarchy of these constants when we want to actually put them into logical groupings, right? So this is kind of an SRE related talk. So we're going to kind of talk about data centers and availability zones and environments and all that good stuff. And this is a pretty naive example. So let's say we're trying to calculate the price for, we're trying to bill a client or something. And we basically use this very naive code, admittedly, where we say, okay, if the data center is data center London, we're going to go ahead and compute the price non-EU. Otherwise, if it's the Amsterdam data center, we're going to compute the price when we're in the EU. Now, this is obviously not legal. I'm not a lawyer. This is not GDPR compliant or EU compliant code, right? But you can see here that there's a little bit more room for optimization and a little bit more ergonomics, right? We still have to have a list of these data centers, and we have to kind of organize them in some file somewhere. Now, one kind of clarification or scope specification that I want to make is that this is not necessarily a talk about configuration values or something that would be updated frequently or updated by a user or updated by some kind of automated service. These are kind of constant values that wouldn't change. So like a data center name, for example, wouldn't really change. You would maybe add a new one every quarter if you're really fast at building data centers. If you're using availability zones, these are things that when you were changing them, they would probably require, if you think about it, they would probably require a merge request or a pull request and some like change consideration. They could be generated dynamically, but for the purposes of this talk, I'm going to only refer to values or magic values that really don't change that often, and it should just kind of live within your code, kind of alongside the business logic. So one thing that comes to mind, if you're familiar with Python, you've kind of gone down a similar path before, is that enums are potentially a good solution for kind of zooming out a little bit and organizing our magic values, right? So enums are great. They kind of, if you imagine the entire environment of, the entire universe of strings, right? Every single possible string, an enum that's of type string will actually provide a distinct subset of these values that you can then coerce, any input from a user or from a database. You can actually validate those strings from the universe down to the subset. So this is a basic example here with the data center. So if we pass, if we say DC soft bracket AMS1, this will basically validate itself to the actual DC.AMS1 symbol. So yeah, they provide a nice mapping between symbols and values. So the symbol here is just AMS1, literally, like you type into Python. And the actual value is the string value that's returned as encapsulated by the enum. I mentioned some form of validation. It's a nice thing to have. And also, MyPy works on them. So if you're not familiar with MyPy, it's basically just an incremental optional static type checker for Python. So it's not necessarily at runtime yet. It's just to lint it's almost a linter, right? That checks to make sure that if you're passing a string into a function that's expecting a string, that type signature is honored, essentially. So it's basically there to reduce bugs statically, and it doesn't really do anything magic at runtime. But we will get to actually a magic way of using these types to integrate business logic, right? One problem with enums is they work well enough for grouping collections of these static values, but they're really not composable. You really can't build a hierarchy out of enums. You can do a little bit of maybe hacky stuff with inheritance and all that stuff. Enums are intended to just be for data as well, so you're not going to find people, or you really shouldn't be anyways, putting methods on an enum. It goes against practice, right? And also there's some confusing syntax around the square brackets versus the soft brackets. So the square brackets are for indexing into the enum's symbol space. So this is like the on the left side here, you can see AMS1, London 1 on the left side, the actual symbol names. And then the soft brackets are actually for checking to find a value that the enum encapsulates. So it's a little confusing, right? We would want some more like ideal ergonomic things if we're trying to update and trying to improve the reliability of our code, right? So this is kind of the core question, right? So eventually, any infrastructure code will need constant values. And how can we build smarter constants that allow for more intuitive programming? And by intuitive, I kind of mean like, if if you were just to show this to your coworker out of the blue, they wouldn't have to understand any of the stuff I'm about to show you. Admittedly, some complicated meta classes and stuff, which I'll probably go into detail in maybe a blog post or something, but not in this presentation necessarily. We basically want them to be understandable by kind of the average developer that doesn't have to know a bunch about Python internals. We want them to be as plug and play as possible, because quite frankly, if something is complicated and hard to use, people will try to look for other alternatives, just like using magic numbers, magic values, putting strings all over the place. So we want this to be pretty intuitive for the user at the end of the day. So we can go ahead and look at some ideal magic values, right? We want them to be type friendly, right? So we want MyPy to be able to dispatch, or sorry, not dispatch, spoilers. We want MyPy to be able to type check and to say statically, okay, this function is expecting, for example, a data center or an availability zone. We want them to kind of behave like a constant, so we can basically use something like datacenter.ams1 to go ahead and represent that AMS type. We want type coercion, meaning that if we do some validation, like location 1 should basically validate to whatever location is under there, right? If we try to validate a data center, it should resolve to that type, so that you can use that later in functions. And I'll explain a little bit of this later with the live code demo. They should be composable, and basically what I mean by composable is that we can do kind of interesting things where we nest like a location under a namespace, under data centers get nested under locations, and the actual like concrete type, the AMS1, will actually get nested further under there. And then it should be extensible as well. We should be able to easily build up business logic based on these simple types. So to kind of go into the composition topic a little bit more, this is kind of a good way to think about this problem, right? Let's say that we have some magic values that are representing the data center within our code base. So it's just like a London and Amsterdam data center. And let's say we want to actually update our code to support a new availability zone. Let's say we're trying to deploy to AWS or GCP or something like that, right? We still want our code to work backwards compatibility with on-prem. We're not going to get rid of on-prem. We kind of want to have a hybrid cloud approach or whatever. And you can see this tree here. The location and data center and availability zone are kind of like, I don't want to say generic necessarily, but they're abstract, right? You wouldn't actually instantiate an availability zone because it'd have to be an actual West 1, West 2, whatever. Same with the data center. London 1 and Amsterdam 1 are both concrete types. And they're concrete values that you actually would see in a database, right? And so anything at the bottom of this tree here is, whatever is a leaf node in its hierarchy is actually going to be a legitimate value that you can validate against and check. So you can see in our kind of ideal arrangement here that we have at the leaf nodes, we define that class, but we also define a value there. So basically, West 2A and West 1A are actually concrete classes now that you encapsulate the real value into them, right? So let's continue on to a live coding demo. Now, of course, this is kind of I was saying, oh, this would be ideal to have, but this is something that I've gone ahead and written. So we'll jump over to a Python notebook. Actually, let me go ahead and move my head so I'm not on the wrong side here. So I've gone ahead and actually implemented this, and you can go through the code at your own leisure. I'm not going to kind of run through all of this stuff, but it's only about, I don't know, maybe 60 to 80 lines of Python metaprogramming. And this code basically allows us to have a constant type that is, composable, has validation built in, has some really good debugging features as well. And we'll go ahead and restart this notebook just to make sure we're starting off. And one thing at the top is I'm actually using a Python or a Jupyter plugin that uses MyPy for computing and calculating the static. It basically does a static check on each of the cells. So kind of a cool thing to have if you do a lot of stuff in Jupyter notebooks and want to make sure that your code is relatively typed. So we'll go ahead and compute this first cell, and as you can see here, really no surprises. This is the same code from the slide. This would basically define our data structure, our type hierarchy, right? So we have location at the top, we have underneath that data center and availability zone, and then at the very bottom with the concrete types, the things that we would actually want to check for, we have all of our actual data centers and availability zones. For those who are not familiar with the MyPy kind of format, this is basically defining a member of the data center class that has a type AMS1. So the internal name is actually AMS1, but the actual type is AMS1 as well. So with this, basically, you have to declare these with quotes because they're not actually, it's basically called for declaration in MyPy, right? Because we have to define them in a certain order, there's a circular dependency here where data center has to depend on something that depends on itself. We have to basically do this for declaration here. So that's just kind of, that's a little bit of bookkeeping there. So we can go and play around these types a little bit. You can see that the type AMS1, this is the type, it's a data center, right? As we would expect, it's nested itself, and the code is basically able to understand that hierarchy and basically give you information about it. Everything's a singleton, so basically AMS1 is going to be equal to AMS1, and this is basically for, you don't want to be spawning a billion different separate objects. You want them under the hood to be all the same object, and this is what that will do. Now you can see that this encapsulates the value, so you can go ahead and use this, as you would use it, right now, the string representation, I believe, is, let me actually do some actual live coding. Yeah, so the actual string representation of this is just the encapsulated value. The repr type is actually going to give you a little bit more information. So you can see that we want to make sure that the identity for the same object is true. Okay, they're equal. We have repr string formatting is working, so it'll basically show you the type here. And I believe this will show, yeah. So this will basically show the type, which is AMS1, and it'll show the encapsulated value, which is also AMS1. We also have validation. So we can basically round trip these values through data center. And what the code is doing behind the scenes is that because data center cannot be directly instantiated, I'll show you that here actually. So this will throw an exception, basically saying that we're never going to instantiate just a data center because it's not an actual type. It's a type rather, but it's not. It wouldn't be an actual object in any database. It's just a generic, right? So when we go ahead and actually pass a function to this constructor for data center, it will actually go and traverse the subtree of it'll find all the leaf nodes, all of the actual concrete classes, and find one that matches the value that you provided. So this validation is now automatic, but it's really smart now. Now, going up a step further to location, you can actually have location now go to its child, and if that child is an abstract class, it'll actually go even further down, so it's recursive. And it'll basically do a depth first search to basically find that value, right? So if we go ahead and look into the type is the same. That's important as well. So this is the type coercion I was talking about, where if you call AMS1, if you do a validation to the location itself, the type will be the same as if you just called AMS1 itself like this. Yeah. This is actually what I wanted to show earlier, is that the instantiated object of AMS1, its string value is going to be AMS1. So it works just like a string under the hood. So then when we go ahead and do the type of West1, which is an availability zone, you'll see that the type is the West1 nested under the availability zone. So this is basically giving us the parent namespace and the actual type. So some kind of cool stuff that comes with this for free is like I mentioned, validation, but the error message exception will actually show you, it will show you which type it's actually expecting. So if you have an error in your log, you can basically see, okay, well, we're passing in this value, but we're expecting AMS1, 1, and 1. Maybe I forgot to update a data center or something. And you can see as we zoom out to the higher level of location, that it will actually start to show you, okay, here are all the availability zones as well. So it's pretty intuitive in that way. And going back to the identity thing, where if you validate a location, you validate a data center, you validate, use the type directly, you instantiate it directly, it will always be the same thing. So this is really important for checking, whether an inputted location is equal to this. You can use the types in all this, dynamic ways, right? Okay, of course, this is a pretty simple example, but basically MyPy will fail to recognize any calls to this location function because, again, it's expecting a location and we've passed a string. All right, so we'll go back to the slides for a sec. There we go. And we'll kind of start talking about the kind of more interesting use cases. So what I've described will probably cover 90% of use cases for people looking for like a slightly smarter constant way or slightly smarter constants within their code base that's a little more ergonomic. That'll cover like 90% of the use cases. Now, what I want to talk about now is the kind of exotic use case, or maybe a different paradigm than you're used to, which is something called multiple dispatch. So I have a link on my website to a really good talk about the unreasonable effectiveness of multiple dispatch. That's actually a Julia Kahn talk. In Python, it's not a default paradigm. So by default, Python does what's known as single dispatch. So if you go ahead and create your class and you have a method, the reason why you have the self keyword there is that at runtime, that self keyword, the object that represents self, is actually whatever type that function is running on. So of course there's polymorphism where maybe that function is going to go up to the parent. There's this whole thing that happens behind the scenes to actually figure out how to singularly dispatch that one function. So multiple dispatch is basically just allowing that in more than a single dimension, or more than a zeroth dimension, basically. So you can have double dispatch, which is two separate values that at runtime the actual function that's calling them will find the precise function signature, the more specific one anyways. And I'll show you a couple of examples, and this will kind of begin to click a little bit more. So we'll go ahead and start with a pretty simple example, right? We're going to generate a function that just creates a VM name. So we're expecting to give it a VM name, or sorry, an FQDN rather. So our function will take a VM name, and it'll basically put out a FQDN that we can use for deploying or whatever, right, to generate these names. So the difference between a data center and an availability zone for the naming is that the data center will look something like vmname.datacenter.mul.dev, and then the AWS one will kind of look like vmname-availabilityzone.aws.mul.dev. So we want to have these two distinct categories, right? So when we go back to the code, we have, if you saw this earlier, of course, we have this. Oh, okay, this is a live coding issue. One sec. I forgot to install multi-methods on my desktop. Okay. Hopefully, it's a save today. Perfect. Awesome. So we're using a library called multi-method, which basically lets Python do multiple dispatch. And you can see here we've defined two separate functions. One that defines a generic, takes a string and takes just a generic location. And you notice this one is going to be raising a value error because we kind of want the base case, so to speak, to be undefined, right? If we have something that, like a new location that we've never seen before, like we have something that's not a data center or not an availability zone, we want to basically raise some error because it's like outside of the conditions or outside of like the logic for whatever we want to compute, right? And then down below, you see we have another redefinition of generate VM name, which is specifying that the location is actually going to be a data center. And so we know what we want to do with the data center, right? We want to print out vmname.location.domain, right? And this will also print out the it'll also print out the location type as a debugging statement. So we go ahead and run this, no surprises. It will generate the correct string because it's basically matching. It knows that AMS1 is a child of data center. So that's the most specific match. It'll kind of do a filter down and we'll return the correct function. So if we go ahead and run this for something with a location that's not a data center, because we haven't defined it yet, it will go ahead and fall back to that more generic location signature and say, okay, hey, we actually don't support this location yet. You should probably look into this. It should be logged somewhere, right? We get the value error. So as you'd expect, we'll go ahead and just we'll flesh out the other part of this for the availability zone. And as you'd expect, once we implemented it, now the generated VM call will work. Cool, so hopefully that's kind of settling in a little bit. It's kind of maybe a weird paradigm that you're not used to. It's definitely it's kind of inverted from the object-oriented programming that you might be used to. But we're going to go ahead and show how powerful multiple dispatch is with a slightly more complicated example. So for this example, we imagine a scenario where we want to deploy a specific service to an environment and also a location. So we have a 2D matrix, right, of places that we can and cannot deploy. So let's say for the purposes of this application, it's okay to be deployed anywhere in prod, right? Or this set of applications, right? It's valid to go into the on-prem data centers. It's valid to go into the AWS availability zones. Anywhere is fine. Let's say for developer purposes, so any app going into the dev environment, we only want to allow deployments into the AWS environment because we have some flexibility there. We don't have the capacity on-prem. We want to basically go ahead and use the AWS environment for devs only. And then for PCC, which is a credit card processing, right? We only want it to be an AMS1, let's say for legal or regulation reasons. So it can never be an AWS. It can only be on-prem. It can only be an AMS1 because it's inside of the EU, and that's where we process all of our credit card information. So you can see this is kind of some complicated business logic, right? We want to kind of, you can think about it as an exercise. You can think about how you implement something like this in code, right? It would probably involve a couple of if statements, maybe you have some kind of table-based approach. I'm going to show you how easy it is to actually implement this business logic with a couple of lines of code and no if statements and in a relatively ergonomic way once you understand multiple dispatch. Okay, sorry, this is the grid I was talking about. Forgot to switch. So this is what I was talking about with prod, dev, and PCC. This will also be in the Jupyter notebook so you can play along at home. All right. Yeah, so this is the truth table, and I'll go through line by line here. So we kind of think about our base case first. What should happen? What should be the safe case? So if we just get a generic environment and a generic location, we don't want to do anything, right? We want to deny the deployment to go anywhere, at first anyways. And we should ideally also log so that we say, okay, this is an unsupported, location. We should log this and make sure that it's surfaced up somewhere so that if we added a new location, we could actually figure out, or a new location or environment, that we could figure out like where the logic is going wrong. So next we'll cover the prod use case here. So prod is permissible anywhere, right? So we can just specify that the location for the prod use case is just location, right? Location could refer to a data center, could refer to an availability zone, could be anything, right? Or anything underneath that. So we go ahead and return true. So this will basically be that top row of the truth table. For dev, for example, we only want to target availability zones. So given that the base case is false for everything, we can just go ahead and paint the availability zone here by saying, okay, we just want to say whatever availability zone we get, this function should call, it should trigger for dev and just a generic availability zone. So that could be West 1, could be West 2. And there's actually a bug here, not a bug rather, there's actually one extra function I needed to remove that. So our last one is basically just to specifically target PCC within the AMS1 data center. So this is the reason why I actually made the types, the bottom leaf nodes, an actual type themselves, so that when you use multiple dispatch, you can actually have them be dispatched based on the actual data center. So if your business logic specifies that PCC can only be deployed on-prem and AWS, you can have the most specific example at the bottom there. And so you can see this is just targeting one of those boxes, one environment, and that will result in one check mark here. So we can run this. Oops, one sec, I gotta run the environment first. All right, here we go. And then we can go ahead and print out the truth table. So we go through prod, dev, PCC, and you can see here that it prints out the correct truth table. And we only had to do this, to the developer, you'd only have to do a couple of lines of code, and this is pretty maintainable. If you wanted to add a new environment, you would understand that for any new environment, there would be no guarantee, nothing could be deployed, and you would just have to manually carve out, the precise types, or you could be at the location level, data center availability. For any set of types or any hierarchy of types, you can actually really precisely target the range of values that you actually want to accept using local dispatch. So that's the end of this talk. That's basically the kind of wow moment there, right? So yeah, thanks for listening. Again, the slides and code, go ahead. It's on my website. It's in a notebook that you can download and play with. It's pretty easy to play around with. It's in a Jupyter notebook. But that's all I have. Thanks for watching.